I'm very glad to have an opportunity to speak to provide an Estonian perspective to these issues of energy efficiency and our cultural heritage. I'm sure a lot of discussion has surrounded listed and protected buildings. However, in the case of Estonia, we have quite a bit of architectural heritage that is not protected, not listed, however, but will still be included in the renovation wave. So I will give a few brief facts concerning where Estonia is currently in terms of the renovation wave and legislation. What do we know about the existing solutions and where to go? What is the approximate outlook for the future? So about myself, I'm Alois, and I work as a project researcher under the Estonian Open Air Museum as part of the Build Us project right here. And without further ado, let's begin. First, a bit about energy efficiency. As we all know, this entire conference is framed as somewhat around this. The European Union has taken the goal of achieving a carbon neutral building stock by year 2050, as buildings currently account for about 40% of the energy consumed in the EU. For this reason, each member state was asked to compile a long-term strategy for building renovation. And these are the numbers laid out in the Estonian legislation. We see that a private or single family or detached houses, however you want to call them, I will be referring to them as detached houses, have the lowest number in terms of total area in terms of the building stock, but in absolute numbers is several times larger, which is quite obvious here. Which means that we have a lot of detached houses to renovate, and we have also considered that a number of buildings will be falling out of use, some are renovated, but the total number we have arrived is 105,000 detached houses. My presentation was centered around non-listed buildings. However, I will be going more in depth in terms of dwellings. So I will be leaving out buildings with a public function and buildings in more urban areas. So I will be focusing more on detached housing in more lower density areas. So in Estonia, a renovated building ought to comply with minimum standards for energy efficiency, which in Estonia means energy class C, which means that in turn the total yearly primary energy consumption per square meter needs to be between 185 and 140, depending on the size of the building. There are 3 different classes for detached houses. Listed buildings are exempt from this currently. And what forms the energy efficiency of a building? We have its boundary surface properties, which affects its heat transmissions, air leakage, and thermal bridging. Its compactness, how the heated space is placed within the heated volume. Is it placed all around the massing, or is it all clumped together? The type of heat source, how efficient it is. Its ventilation solution. Is there a ventilation solution? Is it is the ventilation solution mechanical or natural? What types of auxiliary devices and lighting the building uses? How many of the devices are used and how efficient they are? And what standards for indoor climate have we established? Are we satisfied with, let's say, 15 degrees as an indoor temperature during the winter months? Or do we require higher standards for this? And also that also applies in terms of air exchange. So what can we do to improve the energy efficiency of a building? We can upgrade its boundary surface properties, meaning we can insulate them and we can reduce air leakages. We can upgrade the heating system, which means we can apply more efficient or use more environmentally friendly heat sources and more efficient methods of heat distribution. Ventilation, we can apply a ventilation system with heat recovery, because if we need to reduce air leakages, that means that any form of natural ventilation needs to be switched off, and all ventilation needs to be done mechanically. But that also gives us the opportunity to use heat recovery. And the question of how many and what types of auxiliary devices do we use? Do we use more devices, less devices? Do we upgrade their efficiency? Do we replace older devices with more efficient ones? And can we produce energy locally from renewable resources, which is where photovoltaic panels come into play? What we can't are unlikely to change are the compactness of our building, rearranging any heated space that can be very costly and isn't really sensible in a building usually if it's historic. And the standards for indoor climate are another area where we can't really make currently it has been established that we shouldn't make any concessions in terms of indoor climate. We shouldn't accept lower indoor temperatures or poor air quality. However, there are points of discussion around this as well that can be had. Now, we have looked at the energy performance side, but we also need to take into consideration the architectural quality of the renovation project, as that is not, I would argue, is not only an issue of aesthetics or heritage, but also it has a quantifiable dimension in the building's life cycle. Here's an example where, with the goal of achieving higher energy efficiency, the outer wall has been insulated, but while doing that, any historical character of the building has been lost, and all we get is this like white square in the end that's supposed to, I don't know, create a better facade dynamic or whatever. So, yeah. So, I would argue that if the renovation project begins, or the building owners begin renovation projects by replacing the historical details and materials with relatively cheap modern products, they ignore the structural issues or use improper repair techniques. Sure, the building, once renovated, let's say that the renovation solutions are fine for like 20 to 30 years, but after that, the renovation will need to be renovated. And the negative scenario is that when you're looking at the building, everything original has been lost. The building doesn't really look that good anymore. There's a lot of structural issues. And in the end, the worst scenario is when the homeowner starts to question, why should I renovate this building? And the worst scenario is when the real estate value of the plot will is more profitable without the building than with it, which means that the owner is more motivated in actually demolishing it and selling a clear plot to a developer or a homeowner who would like to build a new home on this plot than renovating it, which means that improper renovation where the building loses its architectural character has an impact in the life cycle of the building, which has an impact in the carbon footprint in the building as well. So this is a case from Tallinn. What happens when historic building is renovated into an anonymous box? Yeah, that building actually was in a protected zone, I'm pretty sure, but during the 2000s, it received a new facade. The windows were replaced, a new roof, probably a new heating system. Pretty sure the interior was gutted as well. And in terms of energy performance, the building might have been fine, but when it came to what actually happened, the building was torn down because people weren't either motivated to step in, or it might have been actually that the plot of the land was more valuable without this building, basically. So this is like an example where improper renovation actually destroyed the value of the building, which also had an impact in its life cycle, which meant that the carbon footprint of the potential for a building with a lowered carbon footprint was ruined essentially. And what happens when a historic building is renovated with attention to details and proportion? The cycle can repeat itself. Sure, this is a building from the museum right here. This is actually our office building. So this building was also probably somewhat in danger of receiving this early 2000s Euro renovation, Euroremondi renovation package, where all detail might have been stripped. It might be insulated, but luckily, but the all architectural character was in very much danger. Would have been very big danger. However, we see that that did not happen, and all the architectural details were preserved, and they were able to be reused or taken as an example when renovating the building. And in 50 years, probably, this building has a higher potential of being renovated again, because the value is there, the inspiration is there, the heritage is still preserved in that way. So I've spoken about listed heritage and briefly about listed and unlisted heritage. Now, unlisted heritage is the part of the building stock. Well, the exact definition of what is heritage and what is not is in the air. However, we here agree that most buildings erected before World War II do carry some aspect of cultural heritage with it. So we know that approximately 30% of the detached housing stock in Estonia was built before World War II. That makes that about 60,000 buildings. And we know that the predominant construction method for these buildings was log. And most of these buildings do represent some aspect of cultural heritage in Estonia. In terms of whether these buildings become listed or protected or not, we have three ways for heritage building to be placed under some form of protection, either national or local in Estonia. They can be listed. They can be by building, by plot, or by complex. We have more than 5,000 listings today. We can list an entire area or settlement. We have about 12. Then these two first aspects are listed objects that we can count. The next two, protection zones and milieu-valuable areas, the exact number of buildings in those zones are more difficult to estimate. And then the third option is any architectural heritage within national parks, where the natural environment is protected alongside the local cultural heritage. So for an old building in a rural area to be protected, these are mainly the only methods that can be considered. Examples of unlisted heritage that might not fit under those umbrellas can be barn dwellings in Estonia, the most archaic form of dwelling, or they might be detached houses without the barn dwelling is characterized by its threshing room, where under one roof the agricultural rooms with an agricultural function and residential function are joined under one roof, or it can be entirely a building with an entirely residential function. Then we have early 20th century farm architecture from both wood and stone. And then as examples from 20s and 30s, from the time of the First Estonian Republic. Now these are the nicer ones. These are what the average picture more or less looks like. They are used as summer homes, or it's also quite common for the upper floors to fall out of use, which means that the residents use primarily, for example, the lower floors, which leads to some form of neglect on the upper floors. These buildings, the owners try to renovate them, but they somewhat understand that they have a building that carries can be considered as cultural heritage. So they understand that it's a difficult project, but still it's their main dwelling. They don't really have a plan B in terms of like an apartment to go during the winter time. So they still need to improve the energy efficiency with any means that they can. Again, going back to the question of replacing the windows. Or we have also examples where they still try to insulate the exterior walls, but then they don't do anything with the roof, or they exchange windows during different periods with different solutions. etc. So this is like the more the average picture in terms of the unlisted heritage that we have in Estonia. And in terms of statistic, the maximum number of dwellings like this in low-density areas that can be potentially classified as cultural heritage, I would estimate is around 40,000. This is the maximum number. It can be. It's quite likely that it can be lower than this, but I still wanted to start with the maximum. And the number that is listed is approximately 50, 0.1%. Now, I don't want to say that being listed is automatically means that the building's cultural heritage can be preserved. Unfortunately, that does not guarantee preservation, unfortunately. But still, this means that only 1% we have any control or over how these buildings are, how the heritage of these buildings is maintained. The rest 950,000 are left entirely to the homeowners themselves to preserve the heritage of that building. Now, what is their existing state in terms of energy performance? What renovation measures do we need to do? We do need to account that these buildings have some form of existing energy conservation measures. For example, when we talk about log buildings, the horizontal placement and the compression provided relatively airtight joints. Internal rendering and wallpaper improved tightness as well. For example, in Estonia today we have this trend of exposing the interior log surface to display this sort of rustic interior, which actually removes a layer of energy conservation in the building. Joints between windows, doors, and walls were tightened and then covered with. They might not be decorated, but any joints between the windows and walls were always covered as much as possible. For example, today in Estonia, when windows are replaced, this boarding between the window and wall can be neglected, left only with insulation foam that starts to decay very quickly in the sun. We applied the internal winter window frames for the colder months. The traditional window type in Estonia. The summer frames open outward, and then for the winter we have another frame that is one large monolithic frame that doesn't really open. There can be like a ventilation section that can be open, but usually they basically install this sort of double glazing principle even in traditional dwellings. Also, the internal layout of dwellings provided the opportunity of dividing the house into sections with different levels of indoor climate. This is, for example, any entry halls, verandas. For example, when in winter you open the door, it doesn't lead into a heated chamber right away. You have this sort of transitional spaces for entering the building, so that the heat doesn't escape out through the open doors. And you have winter and summer rooms. Rooms that you heat during the winter, and then rooms that you do not heat, that you use only during the summer months. And also, the modern expectations for indoor climate have become somewhat distant from the way of life that these old dwellings were built for. Having low temperatures on the floor and putting on like woolen socks and wearing an extra layer of sweaters was not. It was part of the way of life in these buildings. Like today's expectations that I want to walk barefoot in the house and I want 21 degrees everywhere. There is a gray area in how appropriate such requirements in a historic house actually are. And also the aspect of ventilation was provided naturally through the air leakages in the windows, through any gaps in the doors, and it functioned thanks to heating stoves. So nowadays, when we seal the air leakages, we seal the windows, we use heat pumps, we arrive at the problem that the building isn't ventilated anymore, which leads us to the requirement of using mechanical ventilation. And in terms of the measured energy performance of such historical dwellings, unfortunately, while we can apply these sort of passive or energy conservation measures, the energy class does not go beyond class G. And studies show that the most effective measures are insulating the external walls, installing ventilation systems with heat recovery, and improving heating systems. Insulating the external walls is among the most, let's say, controversial energy conservation measures, because that has there's the danger of defacing the facade with the external insulation. However, we can't really get over the fact that it is among the most efficient energy conservation measures. And in Estonia currently, to achieve energy class C, the following deep renovation works are generally necessary. And this list is quite rigid. There can be examples where, let's say, you insulate the roof, let's say, a little bit more, and you can like insulate the walls a little bit less. But these numbers, for example, 200 millimeters of external insulation, 200 millimeters of insulation of the roof, double or triple glazed windows, etc., etc. These measures are in this full list is unfortunately commonly necessary if we don't apply any exceptions to these unlisted buildings. And the question of internal versus external insulation, experience shows that any more than 5 centimeters of interior insulation can be problematic in terms of moisture. So it is possible that perhaps with calculations and moisture barriers and ventilation, a little bit more is possible, but the 200 millimeters that you generally need for the required energy class is not possible when insulating the interior. However, external insulation is safe in terms of any condensation and mold and bacterial and fungal growth. And there have been studies where, let's say, we have an actually listed building or protected building, and there have been explorations, okay, can we somehow maintain the proportion of the building pre-renovation with adding insulation with equal means throughout the entire dwelling? And for this example building in Võru, they did achieve this, that the external silhouette of the building remained exactly the same, although the added insulation thicknesses are also up to the required amount. So experience shows that if it works on listed buildings, there is potential that we can potentially apply it for unlisted buildings as well. However, we can't underestimate the cost of such a renovation project. And also, renovation works, while they may be motivated by raising the energy performance, deep renovation works must also include improvements to meet the following requirements in Estonia. So we start with structural stability and load-bearing capacity, fire safety, having a clean, healthy and safe living environment, safety of use, noise protection, and then number 6 is conservation of the resources and energy efficiency, which means that works on energy efficiency should also ensure that the structure that is being renovated or the dwelling as a whole also meets these requirements, which one can imagine makes the renovation project even more complicated. And the main idea is that there's no sense to adding insulation to damaged structures, which means that we also need insights into what is the technical condition of the housing stock in Estonia as well, that before we talk about any energy conservation measures and adding insulation. So we have done several studies in Estonia to explore this question, to understand what are the homeowners doing currently, what have they been doing, what are they planning to do, and what is their mindset. So I will be introducing roughly 3 studies, or like different aspects of each study. So the first study had a fieldwork method where a number of buildings in the Esno and Kareda region in Estonia were inventoried. There were 2 types of buildings generally. There were log houses built between 1900 and 1939, And then we had the Soviet era, more modernized architecture from the 1970s to the 1980s. So there were like these two, and which were also built from aerated concrete. So we had this like two different building typologies that we were also able to compare. And the rundown of the different building types, log buildings are here. We had 29 detached houses, 6 more archaic barn dwellings, 2 modernized barn dwellings, and 73% of these buildings had permanent residents and were used year-round, which means that insulation and energy conservation measures were very important. However, 27% were in use for limited periods, for example, as holiday homes. And for those owners, renovation generally entailed was described more as repair and maintenance rather than adding insulation. So looking at what the homeowners are renovating and fixing, we can see that the highest parts, the building parts with the highest renovation rates are the interior, the windows and heating systems. And the lowest are rainwater systems, which were critically low, roofs and foundations and floors. So basically anything that the homeowner can see on an everyday basis was of the highest priority, and anything that was more concealed, let's say, I have a theory that the foundations that can be very low, covered in like foliage and very low to the ground, they might be the parts of the building that the homeowner actually literally noticed the least, because they have the smallest surface area, and they had the smallest likelihood of being renovated, because there's probably this sort of like trends in terms of like the renovation practice. So I insulate the walls and the windows and the roof and to replace the heating system. That perhaps like renovation of foundations is that perhaps just not that common between discussions of homeowners that homeowners have with each other. And we also noticed that the renovation is generally done in stages, meaning that the homeowners phases out their renovation works into like manageable steps that they can like imagine. They do it by building section, they do it by room, they do it by facade, sometimes even window by window. And why the windows, the interior and heating systems are the most common, it's likely that their poor condition is the most noticeable on an everyday basis. If you live inside a room, you notice if the wallpaper is poor, you notice if the window has a draft, you notice that if your heating system is poor. So this is likely why these are the most commonly renovated aspects of the building. However, we know that the actual energy savings that you have by renovating a window is actually not that noticeable. Yeah, in terms of thermal comfort, sure, you might have less drafts during the winter, but in terms of the total energy performance, it might not be that great. It depends on the building, how much window area the building has, how poor the original windows are, but it is not among the most efficient energy conservation measures. And well, doing the interior is just aesthetics, basically. And yeah, again, while the foundations, the floors, and the roofs are the least done, the work is likely very inconvenient. You can't really replace a roof in stages. Well, you can do it, but it's difficult. And like also renovating floors, you can't really live inside the room if you need to replace it. So if you don't really have enough space for the family to like move out of one room and into the other, perhaps, then it might not be possible of renovating the floor. And also the owner's lack of technical know-how or awareness of good building practices. There's very much this culture of self-building or consulting your relatives, your friends, your neighbors, and like building forums online in which kind of energy renovation measures are the most proper and which kinds of material to use. There aren't really that many technical trustworthy information sources available today yet in Estonia. We are improving that. However, a lack of technical know-how is technically an issue. And when looking at what is the average condition of these structures? You may notice that some structures are not present due to a technical oversight. Some of these structures were simply not inventoried due to human error, but they were evaluated with a score of 0 to 5, 5 being very good, 0 being critical state, needs immediate renovation. And we can see that the average condition ranged from satisfactory to good. No structures are perfect, let's say. And when comparing it to the other building typology, the aerated concrete buildings from the 1970s and onwards, I can say that their technical condition was better. And we can see that in terms of block buildings, the highest overall condition were upon the structures that were most commonly renovated, the heating appliances, the interior, and for example, the doors. And the lowest condition was noticed for the least renovated structures, again, foundations and drainage systems. And also comparing unrenovated and renovated average conditions, we see that the condition does improve. However, no average condition reaches the optimal state. And again, comparing to aerated concrete structures, they were much more closer to the perfect score than these historic block dwellings. And we noticed also that heating systems were a point lower after renovation when comparing to pre-renovation state. And this was a bit confusing, but I have a theory that this is likely owing to the fact that if a heating system is updated, the most common solution was having an air-to-air heat pump, which was accompanied by a broken stove or faulty heating system, which brought the overall average score of the entire heating system of the building lower. So the building was renovated, but as a complete whole, the heating methods of the building was poor, because for example, if the air-to-air heat pump fails due to an electrical shortage during the wintertime, that building has no backup anymore. So that is likely what is going on here with why renovated heating systems were not in an optimal condition. And also, we ranked these buildings. We had 37 buildings. We added up all the condition scores of each structure and also compared how many renovation works were highlighted. And we're looking at the lowest end of the ranking. This building was lived in during inventory. This was someone's house. The number of renovation works was 0, and it was the absolute lowest building. And we see that the next building isn't doing any better. We see that the homeowner is doing something, but the renovation works are uncoordinated, they're haphazard, and the technical condition of the structures was not being improved, very likely. This is the middle area. We have, let's say, 5 renovation works or 5 structures somewhat renovated. We get the average ranking. This is where we see, let's say that the historic windows have been replaced with PVC windows. We can see that the foundation has been somewhat insulated, but the roof hasn't been, but so nothing has been done with the roof. And for example, here we see that the facade has been renovated, likely the heating system, some windows are replaced, but again, nothing has been done with the roof. And the top of the ranking was interesting. We see that we have 2 buildings. The position or the total score is comparable, 35 and 37, but the number of conducted renovation works was the difference was doubled. This building had renovated 11 structures, this building only 6, but the technical condition was basically the same in terms of this evaluation structure. So this led us to a conclusion that maintenance, preserving the existing structures with yearly maintenance, actually is comparable to a condition where the building structure has been allowed to deteriorate and then the condition has been improved with the renovation works. But in the end, only in terms of technical condition, not energy performance. But this homeowner likely achieved this good condition with a smaller total investment than when compared to this building, which again highlights the importance of maintenance. And this special mention, this had the highest score, the highest number of renovation works, but it was excluded from the sample. Why? Discussions with this owner, they said that they renovated, they improved all the structures, but later it came out that for them renovation meant demolishing the entire thing down to the foundation and building a replica. So this building technically we can't call this a renovation, but this is how certain homeowners interpret the renovation way, basically. And we can see this also among developers and among people who have the finances, let's say, to build an entirely new building, that renovating faulty structures and then improving its energy performance and also its architectural appearance, the cost becomes so great that demolishing the structure becomes easier. And again, it comes down to maintenance, because in terms of the total cost, if the building is not maintained, if you indeed need to make improvements everywhere in the building, then this scenario becomes far more likely for the homeowner. And this is not what we're actually looking for in the renovation wave. And in Esna Kareda, we also looked at the amount of preservation of cultural heritage, inventorying surviving original material, the form and massing of the building, and the architectural details. We noticed that in terms of material and the form of the building, it was relatively okay. However, details are the most vulnerable in terms of these three categories, because they're the easiest to remove, the easiest to replace, and the least likely to be placed back onto the facade once any external insulation has been placed. And it was also noticed that the construction market in Estonia doesn't seem very accommodating to historical details. It needs a lot of, tailored. It requires a tailored approach that might not be very accessible to a lot of homeowners. And we noticed that dwellings built during the 1970s with more modernized architecture, again, since they showed more successful results when compared to historic dwellings in terms of the renovation works, and we can conclude that newer dwellings are easier to renovate. The window division is more close to modern solutions. The facades are simple when comparing these two buildings. And from this, we can also conclude that not all homeowners are placed at the equal starting point. We have the same finish line, C energy class, but different homeowners of different building types some homeowners start from a lot further away than other ones, but we still expect them to have the same finishing point, and that might become a real problem. And not in terms of preserving the cultural heritage, which is definitely another problem that will need to be addressed. But in terms of the renovation wave itself, different building types are some building types are more vulnerable to these aspects. And also, even again, going back to why the construction market is not very well equipped for dealing with these questions. Even if the homeowner wants to preserve the window division, they run into difficulties in finding a good producer for the windows, or knowing how to even order good replicas. These are like two examples from two different buildings. This is the characteristic window division for the building, and this is what the owner came up with. Again, probably the homeowner might not have been perhaps that motivated to keep it. We don't really know what the story was behind this window. We can see like similar lines that they were inspired by it, But again, something went wrong with either the ordering of the window, or how they drew it, or how detailed like the request of the owner was to the factory. And here we see where the owner did put in the effort. They wanted exact replicas, and we can see that like the thought is there, but the proportions are messed up. Was it? It's also almost as if someone orally described the window, but entirely missed the proportions. And we don't know again how the process went, which part of the supply chain became faulty. But this homeowner expressed actual regret in replacing their windows, and regretted getting this result. They felt that they did everything right. They had the resources, they had the motivation to get the best result possible, but something still went wrong. And that was among the most unfortunate stories that we heard. And then there's also the architectural question in Estonia, where a lot of windows were enlarged during the Soviet era. And again, we have different windows in the building. For example, we have this slimmer window type that is divided in half. We have this wider one with a more asymmetric division. Then we have this triple frame solution, and then we get this in the roof dormer window. So which division should the homeowner follow? Which one is the architecturally appropriate one? They ordered this. I believe this is simply the closest thing that they came up with. But even for an architect, this is not an easy situation to work with, actually. And that is another issue that might need to be addressed when helping homeowners. And also, how to combine an authentic window division with modern needs for outdoor access and added daylight. The homeowner wanted a terrace door, and then how do you pair it with a historic window? The division becomes all messed up when you pair it right next to it. And also, if you keep a modern a historic window here, but a modern door here, you can tell the difference, that they're not going to be the same. Like, how do you solve this situation? Do you tell the homeowner, no, you can't have this terrace window? However, the request for more daylight is a very reasonable request, actually, in my view. So this situation is also that we can ask the homeowners of authentic divisions, window divisions, but there is a lot going on here than simply asking them to follow the authentic, simply copy like the old division from photographs, because the existing situation might not even be those windows might not be applicable anymore. They might be wider. They might be extended into doors, etc. And that was Esna fieldwork. Then we also had a statistical method in studying what are the common damage types. The Estonian Open Air Museum provides coordinates consultation services for owners of these historic rural buildings, specifically non-listed buildings, and it has been an ongoing process from 2015. And from 2019, I believe, these actually from each consultation a report is compiled, and from 2019 this report was beginning to be entered into a central database with a fixed structure, which means that all this data can be studied, was able to be studied later statistically as well. And by 2023 we had more than 300 buildings and more than 1,000 structures evaluated. The structure of the report had this breakdown where you have the type of damage, you have the damage structure, you have the material of the structure, photographs, the description of the damage, and a renovation recommendation from the consultant. And each report contained data concerning the construction year, what is the general history of the building, and as I described, the building properties, its structures, the damage types, the details of the damage details and the renovation recommendations. And this statistical info was studied as part of a master's thesis. And the main breakdown was based on building structure, the damage detail, and suspected cause for deterioration. And we did need to filter some of these buildings, so we ended up with 208 dwellings, 115 detached houses, and 93 barn dwellings. We found that the most commonly damaged structures were the walls, roofs, and foundations. Basically, the exterior structures that are in constant contact with external, with the external climate. And then we get to the ceilings, windows, floors, heating, chimneys. Sometimes not even damage was described, or because the reports also highlight if a structure was in good condition or if a structure had any specific heritage value that the homeowner ought to preserve during the renovation process. And we also mapped out what the different damage types can be. As you can see, we have a simple junction between the foundation, the floor, and the log wall, also a window, and the list of damages or potential risky solutions is very long. That the potential for damage transfer was very, very high. You have a damaged windowsill that leads to a damaged log wall. You have a leak in the roof. You have a damaged roof rafter. You have a damaged ceiling beam. Then you have a damaged floor, etc. And even like small things, basically, like foliage against the foundation, or a ground level that has risen during the decades. All of that leads to problems under the floor, in the log wall, and increases again the investment that the homeowner will need to do in the renovation wave. Again, we can talk about the insulation aspect, but all of these potential damages from these small things that are related to maintenance will also need to be fixed during the renovation. And that increases the original investment for the homeowners and makes the process exponentially more difficult for them. Again, everything that can go wrong in a roof, missing or damaged ridge boards, faulty joints of the rafters, broken collar beams, poor water tightness of the roof covering, localized decay between inner roof plates, shifted plate logs, missing rain gutter systems. There again, to state a lot of points where damage can creep in and create a lot of problems that will need to be fixed. And our third study, we also, in terms of heritage, wanted to see how do the homeowners view their own situation, let's say, what is their motivation to renovate, how they have renovated their houses, etc. And that study is very much related to Petra's presentation of the study that we did with Kontorimor. The total sample of buildings included 98,000 homes in Estonia, and we got 978 responses, a very nice 1% representation. It was done as a questionnaire, either online or by phone. And we, again, measured a lot of technical aspects in terms of how do they evaluate the indoor climate, or how do they heat their homes, what renovation measures have they used. But as I've already broken that down in this presentation, I didn't want to go over that again. Again, this time is limited. But I wanted to highlight this interesting question, part of the questionnaire, where homeowners were asked to evaluate the questions of cultural heritage and emotional connection to their building. And we see that if the homeowners were asked whether their house had emotional value to them, purple meant a positive answer. We have 91%. We have a positive answer, which means that 91% of homeowners view their homes as very emotional. They are emotionally attached to their homes. And also 77% say that they value historical architecture. So the ground is there to develop renovation solutions that actually consider the architecture, the cultural heritage of the buildings. There is a sort of readiness to accept the renovation process where these details are a part of the comprehensive renovation process. And the rest of these answers basically support this. I think it's possible to maintain architectural value while improving energy efficiency. 60% homeowners agree with this. And 52% agree that their house is a good example of cultural heritage that deserves preservation. If we break this down into statistics, again, half of 98,000 homeowners believe this, which again, we arrive at the number of approximately like 40,000 buildings that might potentially carry cultural heritage in Estonia. Sure, some homeowners might overestimate this view, some might underestimate this, but I believe that this statistic is somewhat important in keeping in mind how we approach the renovation wave and these owners of non-listed heritage buildings. And the future, briefly, we've spoken about these sort of wooden early 20th century architectural heritage, but also we have started looking at the Soviet period. We have certain milieu value areas where Soviet era detached housing has been declared as somewhat protected. And as time goes on, I believe that this line starts coming closer to us. So right now, our attention might be on this type of architecture, but I posed the question, when does this type of architecture begin to be viewed as needing protection or deserving protection? And on it goes until we end up in the 1990s. Not today, this will be left to decided to the next generation probably, but we need to understand that our actions in the renovation wave will impact how future generations will be able to conserve what they interpret as architecture, as cultural heritage to them. And there is somewhat danger that we are making a decision for them that they might not be able to overturn if they see it fit. And some words about Build Us project. The Open Air Museum is part of two work packages, developing technical solutions and information material for both homeowners and specialists. And part of this work package is studying the detached housing stock, establishing the extent of existing renovation works and their quality, establishing common damages and renovation mistakes, and establishing best renovation practices. And also raising awareness among homeowners and specialists through events, such as this one. But more on work package 2, the previous studies that I showed were all part of that work package. And when developing these technical solutions, I have provided several principles that might potentially be taken into account when these solutions are established. For example, primarily focusing on external insulation or replacing old insulation with more efficient materials, maintaining architectural proportions according to building type, regardless if it's protected now or whether we see potential that this type of architecture might deserve preservation, preserving historical details, or trying to nudge the construction market to make it easier for the homeowner to produce or find replicas, recommending the use of durable and accessible renovation solutions, but trying to ensure that it's also historically appropriate to the building type and the original construction material. So, for example, we don't recommend, for example, if we talk about this sort of rainfall protectors against that's between the foundation and the wall. So this sort of offset that is usually protected with like this slanted board. For example, a historically appropriate solution might be putting back a wooden board, but we know that its durability is not good, so we would recommend placing like a piece of sheet metal across it as well to protect it from decay. So these sort of small improvements, I believe, are warranted, but still, whenever possible, any like historical tradition ought to be preserved. And also providing insight into conducting staged deep renovation. That as we see that there's a large self-building culture in Estonia, and homeowners do prefer to renovate in stages, we also need to take this into account when providing renovation solution, that we don't expect the homeowner to do it all in one go, to provide them with the alternative to do it in like piecemeal steps, basically. Highlighting the importance of junctions, because that is one of the main problematic points. It's not just how much insulation you add, it's how it all meets with the roof eave and the dormer windows. Those are the weak points in terms of the building proportion. Not only the question of how much the new facade is going to be offset from the old one, and taking into account the preferences and likely limitations of the homeowner. And we have established 3 levels of information. First, the information material. We start with the basics. So the basic structural elements of a building, how to evaluate current technical state, how to evaluate the necessary scope and depth of repair works, what are the most cost optimal energy conservation measures, and basics of deep renovation versus stage renovation. And this is to eliminate this first feeling of confusion that homeowners might have. So it's not, the homeowner might not yet be sure which types of renovation solutions to order, but they know the technical terms, and basically they know how to discuss renovation solutions. They know how to discuss with the market, basically. So the goal is to have a more educated homeowner. However, if it's aimed at specialists, they can skip the first level, and we have level 2. These are renovation strategies by building type and by owner preferences. So these are specific renovation junctions and drawings, and or like they first begin with this with a elementary level of saying that, okay, we add insulation to the roof, we add it to the wall, and then do you have any lock-in effects? Let's say that the roof covering is already renovated, you can't really remove it anymore, so you need to add the insulation from indoors, or whether it's even that might not be possible. How to establish what are your limitations, what is your renovation motivation, or let's say motivation, and which solutions are most appropriate. So this would give you an educated client. They already know how to speak. They already know where to place insulation, whether it's external or internal, which kinds of solutions they need, and they can already discuss with designers. So this is like an example of a design documentation that would also be included with these example drawings, where we try to maintain the original proportions as much as possible, and any limitations that the homeowner might have. For example, this is a frame structure with sawdust insulation between the framing, and let's say that the homeowner doesn't want to take it apart from the interior side. They only want to insulate the outdoors, despite the fact that there is a potential of removing this old insulation and replacing it with more efficient insulation. But okay, let's say this is the solution the homeowner wants to have. This is a potential solution of how to do it. And level 3, renovation tactics. Example construction documentation for common structures and junctions among common building types. Now this says exactly in which order to place any materials, how to provide air tightness, how to install the different measures, and this is more aimed at the self-builder, or let's say to give the homeowner a potential of being able to act as a construction supervisor, to understand what the builders are doing, even if they themselves are not doing it. And in the end, all of this hopefully might end up as part of the Building Renovation Passport, which is a concept recommended by the European Commission, where existing energy performance certificates are developed into the sort of logbook and roadmap, potentially online module, where building data is stored in the logbook, and then this provides us a basis for establishing the renovation roadmap with exact renovation stages. What is the priority of each work? What is the size of the investment? Which solutions to use in which stages, etc. And this is slowly in development, but this is the future where renovation advice hopefully will end up in Estonia. Thank you.
That was amazing, and there's a lot there. I think that database, I don't know of another. You guys are so amazing that you maybe all have them, but I think that's something would be very interesting. But the one thing of it that I noticed leads back to the real red flag, which is the rainwater goods. That is a terrifying statistic, because the single best and most important thing anyone can do with building is make sure the rainwater is handled properly, especially because we're talking climate change. That's got to be the priority. So one of the things that really worries me, for instance, with work on the building facade is where you lose the water shedding detailing. And a lot of what people think of as decoration isn't. So what can we do? Because do you record in that database the rainwater goods?
You mean like the rainwater system that drives the building? Yeah, somewhat. As you can see, the basic of having like gutters was a very, very low. Because
if they've got very wide eaves, then I might get rid of it.
Luckily in Estonia we have a tradition of building wide eaves, sure, but I entirely agree, because all of that will lead to a very moist foundation area, which leads to frost heave, which leads to capillary rise, which leads to rot in the lower log walls if the moisture barrier has been decayed or even not been installed. I agree. It is all we can do is raise awareness, I'm afraid.
Of all things that people could do, that's the first thing. They shouldn't be going anywhere near energy until they fix that. For themselves.
I think we have established there's a lot that we need to be doing before anything, and which ought to be done with energy.
I would also like to ask a question regarding your suggestions. So if I understood correctly, you're for the buildings you are leaving existing outer wall where it is and adding insulation from outside. So you're actually stepping over the border with some 15 or 20 centimeters of. So you're like fattening the building, you know. And I don't know. It's a question because in Latvia there are some red lines and regulations which you cannot step over, especially in cities. So it's and also there's a land border. And it usually goes with the building. How you expect people to deal with that if they'll be renovating and stepping actually into either neighboring property if a building is on the border, or against the city which owns usually street.
I must admit that my expertise is more related to low density areas, these sort of rural dwellings where these issues aren't that common. I know that Yllar, who's recording, might have a better answer for that. I hope maybe later you can discuss it. But yeah, I must afraid that I don't have a good answer for it right now. But yeah, in terms of like other like. I must say that in terms of like the rainfall, fattening the facade means that if you're not widening the eave, you bring the facade closer to the watershed, basically. So if you're bringing the facade outward, you need to also like extend the eave, which again restates the point of having a comprehensive view of renovation. You can't view it by wall or by roof or by window. You need to have a comprehensive view with an understanding. For example, if you are renovating your roof, you need to if you might not have the funds of insulating the wall right now, you should already think about your eaves. You should leave them longer already. that they might be left like that for like 10 years, perhaps architecturally it might not look that logical, but that leaves you the opportunity to insulate the roofs in a way that the proportion of the building will be preserved in the end. So it's this long-term view that the homeowners will need to have when preserving the proportions of the building.
Thank you very much for this thorough investigations and service that you have done on detached houses. It's really interesting. I will look into some parts. I think the presentation you had last with the different stages, it's really helpful. So I would like to look into that further. But my question is for you, because you had in the middle of your presentation, you had a picture of two buildings, and then you said this was easy to renovate and that was difficult to renovate. And
I will get back to it.
And we did a study, there it is, about changes in detached houses, and I will use detached houses now. And we saw that the modern buildings, it was actually more difficult to renovate them without losing their original character than the buildings from the 1910, 20 and so on. When you come into this functionalistic architecture, it is much easier to destroy the character of the building than the older one that has they have they can be changed much more before you see it. So I thought that was really interesting, and I just wanted to ask you if you have thought about that in your study.
I understand. Yeah, I see what you mean. I think it all goes down to building type and architectural style. I believe that, sure, like 30s and the functionalist architecture, where like the question of proportion is the balance of proportion is much more subtle and much more easier to ruin. However, buildings like this, I believe that this example is something a bit different than what you might be describing, because this is a mass-produced dwelling. And in that sense, it's more, renovating this building is somewhat more closer to renovating a concrete block apartment building in Estonia. You can like copy paste the solutions much easier than compared to this kind of dwelling that needs a lot more tailored approaches. So I believe that what you might be describing is placed somewhat in the middle, perhaps then, but yeah, this building, when you compare it before and after, it's essentially the same. You have this like small weird nooks that you get where the placement of the insulation was perhaps not completely thought through, but I'm pretty sure everyone would agree who knows what type of building this is, that the character is completely preserved here, 100%.
What's going to happen to it in 20 years?
Which one? This one. We can hope that the renovation solution, that the existing renovation solutions don't need renovation before the homeowner gets to the unrenovated structures right now, because that is the worst situation, where you do it in stages. You don't really perhaps know what you're doing. The material is not that good. The finishing is not the best in terms of warding off decay, and you discover that when you're starting to renovate, let's say you did your walls, and then 20 years you do your roof, you notice that the wall needs replacing also.
Or that you've got such damage that it becomes very hard.
Yeah, again, going back to that, or the renovation solutions are so haphazard, the repair has not been done, maintenance has been neglected, the list of works is just so great, there's nothing left in the building even.
And if they're never renovating their rainwater goods?
Well, I will say that rainwater goods are not that traditional, perhaps, in Estonian rural architecture, so if it has survived for centuries, I don't know.
I didn't have the insulation. That's what worries me. It's going to trap the water.
Yeah, I just want to return to you for your remark about the about the plaster on the buildings in Akko, that you mentioned the ripping off of interior in order to expose the logs. And I think this reminds indeed what today is considered as beautiful, the facades of stone, and you see the material and it's old, and but it's sometimes architects come when they come to work on buildings in Akko and they say, yeah, but that's what the client wants. He wants this authentic thing, and it's very difficult to convince them that
authentic
plastering and that it's not a matter of beautiful or authentic, or it's a matter of building physics.
Yes.
And then finally also climate. But that's very hard to convince, and today it's a matter of fashion. Yeah. I think always there were fashions, but not to extent of how you build your house and that it stands the weather and physics.
Good. You also wants to add something.
I can continue this point just to drive one more message home with leaving the plaster or taking the plaster off or replastering a stone building or any building for that matter. Originally the idea was that this does get affected by climate over time, but it protects the stone. So there is an assumption that there is maintenance in the process, because after a while it will deteriorate and then you have to replaster it again. And this is maybe the biggest in some ways, the biggest consideration in all of these. I don't know if it's relevant to these buildings, but there is an expectation that once we renovate, we won't need to do it anymore ever.
The illusion of a maintenance-free building is very prevalent.
Yes, so
it's not the point that once you apply the plaster or once you install the facade boarding, once you paint it, I expect it to last 100 years. You're supposed to freshen it. You're supposed to protect it, because that is what's protecting the main load-bearing structure. The rendering, the wood facade, the paint, its point is, in a way, is to decay, so that the inner structures don't decay. It's a sort of sacrificial part of the structure.
Then the last words. Alois, thank you very much.